Hello, everyone. You are welcome to lesson 2 of statistics. And we are looking at the core math aspect of statistics, which is also in relative math. So, okay, so in the lesson 1, you were given this assignment and you were asked to do A, B, and C. We'll look at the D and the rest, okay, God willing, today. Okay, and the advice was, or the instruction was, though the information came in the raw data form, okay, we were asked to move from the raw data to the corresponding, okay, on group frequency distribution table and use that to, okay, find the measures, okay, that you have here, these 3 measures. Okay, so by so doing, you were supposed to have this as what? As your solution. So as usual, solution is what you write first. Questions are numbered because we always want you to also number your solution. So we are looking at the solution to question number 2. And I've told you any information, so this was the information. Here you are moving from this raw data to group frequency distribution table. So you look at what the minimum, okay, and you move in that order because you know that for an group frequency distribution table, your numbers must be ordered this way. It will be decreasing down, sorry, increasing what's downwards. It will ascend, okay, downwards. So the least value is what 11. The next one will be 13, followed by 14, 17, 19, 20. None of the numbers here should be repeated. The repetition will be taken care of by what the frequencies. And after doing that, okay, after getting your values here, your distinct numbers here, and in that particular order, the next thing that you need to do is tally. Tally is to make your protect your marks basically, so that you avoid, okay, omissions and maybe double counting. Okay, so you know when you are tallying, this is what you do. Okay, in JHS, you were told that you cross it, immediately you cross it, you come and what tally. So you cross what 14, you tally, okay, 14, 1. You cross 14, you come and tally again. And you know how to tally, so I won't waste time on that. And please, if possible, when you are tallying, okay, make sure you tally in pencil because something can go wrong so that you can easily erase. Am I clear? Okay, and after your tally, then your frequency what comes. So indeed, what we have here, you move from the raw data to a frequency distribution table. And we know, okay, after getting your frequencies, and we said the max will be in terms of X. When you quote the formula, okay, your formula will guide you as to what to do. So IA, we are supposed to find the mean. And we know that the mean, which is S bar, you can even choose not to write the S bar. Okay, just write the mean. It's equal to, we know, from the group or on group frequency distribution table, the mean will be sigma fx over what? Sigma f. Okay, so what do? You go and look for where your f is, where your x is. So we know that the x will be the individual, the mass that we have there. And so you write that and you put it in bracket. Always let us know your x, let us know your f. Any parameter that you use, okay, let us see the labeling in your table. So the x, you put it in bracket, and frequency, you also put it in bracket, or you can write it on top. Okay, on top. Okay, and remember here, you just write fx. Don't write anything. Don't write product of f and s. It's just fx. It means the product of f and s. The advice was not to write it this way because it could have another possible meaning. The meaning will be ambiguous, which will be f of x, a function, but that's not what you mean. It's really the product of f and what and x. So you come and do that, okay, out to this. And Benin, okay, this was supposed to be 2. Okay, you put 1 here. That was the issue. And immediately you get that wrong. Any of the values, especially the frequencies, wrong. And any of this wrong, obviously, whatever you are going to do, that will involve them wrong. So you have to be very careful. In this case, you shouldn't have gotten the frequencies, okay, wrong. Because when you sum, you were told that you were dealing with 15. So when you sum, you should have add 14 because you used this value to write it here. You didn't sum. That's what happened to you. So if you are summed with your information here, okay, you would have seen that what you have there was 1 short. So you go back and remedy the situation. Unfortunately, you didn't do that because you knew it was 15. You just wrote 15 years straight away. So take note and out of this experience, next time, make sure it doesn't happen to you. So now what do? We go and find the sum. We need it, find the sum, we come and substitute. So the mean mark will be what? 15. Okay, then you come to the median. And we know that the median, we need to first of all state the median position. So we know the median position will be given by, based on what we did. He said it will be sigma f plus 1 all over 2. Then TH, the TH is telling us that we are dealing with the position, not the median. So at the point where the TH is not there, then you are telling us that that is your median. So you have to be very critical. Okay, so here, I know this will give me sigma f is 15. So 15 plus 1 over 2. Okay, position. And I can move from here to here straight away. I decided to write. So this will give you 16 over 2 position, which is the H position. So you come to your table. You are looking at the observation that will occupy the 8th position, and that will be your median mark. Okay, so if you come here, the frequency is 3. So it means from the first position up to the 3rd position, it will be occupied by what? The normal level. So here you don't have to go and arrange your number, because in the frequency distribution table, indirectly, okay, your numbers are arranged. So from 1st to 3rd, okay, will be 11. From 4th to 5th will be 13. You keep on adding. So when you add, we are going to get what? 9. Is that not? So it means from 6 to what? 9 to be occupied by what? 14. Meanwhile, you want the 8th position, and the 8th position will be between the 6th and the 9th, okay, that you have here. So it will be, okay, in this what? Frequency. So you move, and that will give you the 14 as the median mark. Is my point well made? Especially those who are joining us, okay, for the first time today. I hope you are following.
Yes, please.
Okay,
Yes,
please.
please.
So you come and draw your conclusion. The median mark is equal to 14. Very. So the 8 here is the position. So all along, as you are dealing with the position, don't forget the, okay, what you need to attach, the TH. Okay, then the modal mark. You know that the modal mark will be the mark with the highest frequency. You come to the frequency column. The highest frequency is 4. And the mark that is assigned to that is what? 40. So again, the modal mark will be what? 40. Okay, Cooks. Professor Kukwa. Please unmute and respond. Your hand is up. Okay, all right. Okay, unfortunately, okay, unless maybe it was an accident, it wasn't intentional. So this will be it for the solution to the assignment. We will continue, okay, from D. Remember, we didn't do the mean from what? The assumed mean perspective. So that's where we are going to continue, okay, from. So let's look at our last measure of what? Central tendency, which will be, we are still looking at the mean, okay, but the mean from another perspective, what we call the assumed mean. And here I'm only going to introduce you to the formula. Okay, ordinarily, that's not how I teach. I will let you know what went into the formula and we will derive the formula together. But because of time, you know, we need to cover. You just need the formula. So I will just give you the formula and help you to remember the formula. So we are looking at what mean from the assumed mean method. So assumed mean method, finding the mean. Okay, so again, I'm going to look at, first of all, okay, the mean from the assumed mean method, looking at what? A raw data. Remember all our formula, okay, we said we get it from what? The raw data perspective, especially the, okay, and the frequency distribution table. So anytime you are dealing with what? The assumed mean method, your mean, which is the S bar, always be equal to your assumed mean. So usually your mean that you have assumed, okay, is represented by A. Okay, then plus, okay, the mean of the deviations of each observation from the mean that you assumed. Okay, and we are going to represent the deviations by D. So I'm looking at deviations, I have deviations. So if I'm finding the mean of deviations, then it means I have to sum the deviations and divide by the number of deviations, because if I want to find the mean of any set of numbers, it will be the set of numbers put together in terms of addition, okay, over the number of what? Numbers that I am confronted with. So I said it will be equal to your assumed mean. Indirectly, that's what I said. So your mean will be equal to the assumed mean plus, okay, the mean of the deviations. Okay, birthday, so the assumed mean plus the mean of the deviation. But the mean of the deviation, remember the deviation will be represented by D. I will throw more light on that. So if I'm finding the mean of the deviation, then it means I need to sum the deviations and divide by the number of deviation, which will always be the same as the number of observations. So it means from the raw data perspective, the assumed mean method in finding the mean is given by the formula, the assumed mean plus the mean of the deviations. However, here your D, let me write A, where A is equal to the assumed mean. So I'm defining my parameters. And my D, will be equal to the deviations of each observation from the assumed mean. So the observation will be X, and from the assumed mean, it will be A. So it will be your observation X minus the assumed mean. And here I'm dealing with raw data. So I'll be giving X sub 1, X sub 2, X sub 3, up to what? X sub n. So you know your X. So each X, you subtract the mean that you have assumed from it. Then your result, you sum, then divide by n, and you go and add it to the assumed mean. And it will always land you or give you the exact result as what your true what mean. So remember yesterday, we had a clue as to how to move from the raw data formula to the frequency distribution table, formulas. So let's look at, the second one. So now, I said raw data. So let me look at this as A. Now B, let's go and look at it, from either the grouped, let me use grouped frequency distribution table, or ungrouped, frequency distribution table. I'm using this for short, so that maybe we save time. But it's not universally accepted. So group frequency distribution table, then ungroup frequency distribution table, they will all have the same formula. Only that from the group, you will do more work. So in this case, X bar from the assumed mean method will be equal to your A plus, remember I said in terms of the frequency distribution table, your N becomes what? The N becomes
F.
Are you sure it will be F? Not F. I didn't say F. I said something. So not F. Okay.
Sigma F.
Sigma F. Is it clear now? And I said, right after the sigma, what comes? If you see sigma in the raw data formula, if you are moving from the raw data to the frequency distribution table and you see sigma, right after the sigma, what should come?
F.
F. Then you attach what is left there, which is the what's it. That's all. Your D will still be X minus what? A. However, if you are dealing with group data, the X will be known. But if you are dealing with a group data, the X will not be given directly. Remember, you are going to find the midpoint, which will be your X value. So for the group data, you will find your X. For the ungrouped, then the raw data, the X values will be known directly. You will not find them. Is my point well made? So now that we are familiar with what the formulas that we have there, let's see how best we can use the formula that we have here, deal with what the following questions. So this was it in terms of what let me see. So let's look at, we are going to continue from here. Let's see what will happen under this perspective, because I will be editing. I will move to the editing mode. So when it's necessary, then I go to the presentation mode. All right. So at this point, let's see how best we can find the mean mark using an assumed mean of what? Of 15. So we are going to look at the solution to that of what? Of the D. Solution to question D. So let's see, how best we can do that. So D, Okay, let me see if I can change my marker to red. Okay, so D. Okay, what are we looking for? We've been given an assumed mean. So you extract, giving, okay, assumed mean. And your assumed mean, comma, A to be equal to what? Okay, 15. That's what you've been given. Okay, that's your assumed mean. However, from the assumed mean perspective, you need to know the formula. And I've told you that anytime from now, okay, ongoing, you know, anytime you are given a raw data, always move the raw data to the frequency distribution table. Okay, it's always better. Okay, it is always better. So that's the more reason why you don't have it in the ungrouped, sorry, in the raw data format, rather the ungrouped frequency distribution table. So from your ungrouped frequency distribution table, you know that, okay, your mean S bar, okay, will be equal to, using the assumed mean, it will be A plus what? Sigma FD all over sigma F. Is that clear? Hello, is my point well made? Okay, where we know that D will be equal to X minus A. So it means we need to go, before you can find the product, as for the sigma F, it is already here. Before you can find the sum of FD, you need to create, okay, a column for the D, because D will also come from a certain calculations, which will be, okay, X minus A. So we need to go and create a column for D. Okay, so this is what I am going to do. Okay, I am going to more or less introduce extra columns here. So I'm creating room there. So this one, this time around will be D, your deviations. You need to find your deviations. And we know that the D will be equal to what? X minus A. So X minus what you are assuming A. Is my point well made?
Yes, please.
Okay, so we are going to, the whole of this will go, I will edit together with you. Okay, so now this is your X, remember. So your assuming is 15. So X, 11 minus 15 will give us what? So you know it's going to be X minus A. Your A is what? Your A is 15. So all the X here, you subtract 15 from it, and that will give you the values here. So let's do the editing together. Okay, hey, what do we get? 11 minus 15 will give us minus 4. Okay, what about 13 minus 15? Minus 2. I hope you are following. Kukua.
Yeah.
Yes, please.
Please, can you go over to find the assuming again minus
No, your
connection?
line is bad. You said, come again. What did you say?
Go over how to find the assuming again. My line kept on disconnecting.
Okay, so no, as for the assuming, okay, it will be given. Okay, so you are supposed to
Yes.
use it. So the assumed mean is given. Only that we are saying that for you to find the actual mean, it is given by the assumed mean plus, okay, the mean of the deviations. And in terms of a frequency distribution table, the mean of the deviations will be given by summation of sigma FD all over sigma F. So here, as for the A is known. So always the point is, what's the formula and let the formula guide you. In the formula, we need A, but A is known. Okay, we need sigma F. Once F is known, we will know sigma F as well, because we can sum this. And we also need the product of F and D for us to sum. However, we don't know D. So how do we find the product of F and D for us to even go and sum? So it means the first point of call should be finding the values for D. And we know that D is equal to what? X minus A. That is the deviations of each observation from the assumed what mean. That's why we are calling it the deviation. And deviation must always be from a particular value. So deviation of the observation from the assumed mean. So each observation you subtract the assumed. So it means here, if I take this, if I want to get the D for this particular, okay, line or row, I need to get 11 minus what? Minus 15, and that will give me minus 4. Is it clear now? Is it clear? Okay, so let's move on. So 14 minus 15 will give us minus 1. Okay, then we come to what? 17 minus 15 will give us 2. Okay, then we go to 19 minus 15 will give us what? 4. Okay, then we'll have what? 20 minus 15 will give us what? 5. Is that clear? Okay, we don't need the summation of the D. So this one, we don't need any value there. Okay, however, you know, we need to go and create, okay, we need F, the product of FD. So we have to create a column for the F what? D product. Okay, so quickly, let's see how best we can do that. Okay, so I'm going to look at the product of what? F then D. Okay, so let's continue here. Give me the results. Now you have F is here, D is here. So this row, you are going to get what? 3 times minus 4, and that will give us minus 12. Am I right? I hope you are following.
Yes, please.
Okay, then this one will give us F times D. So it will be 2 times minus 2. That will give us what? Minus 4. Okay, the next one, here, help me. 4 times minus 1, and that will give us minus what? 4. Okay, so let's continue and see what is going to happen. Then 3 times 2 will give us what? 6. Okay, I hope you are following my professors. 1 times 4.
Yes, please.
What? 4.
Yes.
Okay, then 5 times 2 will give us 10. So we'll need a sum. Okay, so this time around, I'm going to take this. Let me copy this. Okay, or I can still, okay, get it from what we have there. Okay, so let's use the sum. We are looking at summation of what? FD. Once you know you have the FD column, you can find the sum. So the summation of FD, okay, will be equal to. So sum this and give me the result. I'm waiting for you, my professors. I'm waiting for your results. You can do this mentally. Zero, right?
Yes, please.
Okay, 0. And okay, it should be 0. Obviously, if you are smart, it should be 0 because you know that this data, we found the mean, and the mean gave us what? 15. So it means the person's assumed mean is coinciding with the true mean. So anytime you have this situation, then it means, okay, when your assumed mean coincide with the true mean, when you sum your FD, you should always get 0. When your assumed mean is less than the true mean, when you sum this, you should get a positive result. When your assumed mean, okay, is more than the true mean, when you sum this, you should get a negative result. Should I come again, or my point is well made?
Please come again.
Okay, you can see that, okay, we are saying that it will be your assumed mean plus a certain quantity. Okay, so if you assume a correct mean, which usually will not be so anyway, if you assume your assumed mean coincide with the actual mean, okay, in this case, then it means my actual mean is supposed to be the same as the A. And under what condition will X bar be equal to A? It's only when what you have here, you add nothing to it, that it will coincide. However, okay, if let's say I assume a mean of 17, meanwhile the true mean is 15, okay, under what condition can I get this to be 15 unless I subtract something from it? So it means the quantity here will be negative so that I can subtract something from it to get what? 15. Because if what I have here, obviously, is greater than the true mean, okay, and I get a positive result here, then it means if I add that positive result, I'm going to move more away, okay, from the true what mean. However, if maybe I assume a mean of 13, okay, 13 is what? Less than the true mean. So for me to do the calculation here, land at what? 50, then it means the result here should be a positive result so that I can add it to this to get what 15. But for me to get 15, I have to add something from this. I shouldn't subtract. However, for me to get 15, I have to subtract something from this. That's why I said if you assume mean is more than the actual mean, okay, the quantity here, which will come from this, okay, you know, should be what? Negative. If it's less than, the quantity should be positive. I hope I'm clear now. It's just some basic analysis that we've done here. It's my point well made now.
Yes, sir.
Okay, so at that point, I'm going to clear this. I need you to find or to continue. So now we are going to carry out our substitutions. Okay, so let's go and do the substitution together. So at this point, if you continue, we are going to get what? S bar to be equal to your assumed mean is 15. Plus, remember the summation of FD gave us 0. 0 over your N, your sigma F, which is what? 15. So you are going to get what? Your mean to be equal to 15 plus 0. I'm just writing it for explanation's sake. Otherwise, you don't write it. Okay, so it means now I can draw my conclusion. Therefore, okay, my mean mark, okay, mean mark, okay, will be equal to, and I've obviously used the assume mean method, and that is the same as what 15. So whether you use the assume mean method or not, you have to end up getting the actual mean. So here we are looking at the assumed mean to get the actual mean. So if you use the normal way to get the actual mean and use the assumed mean method to get the actual mean, the result must be. It's my point well made. Hello, it's my point well
Yes,
made.
please.
Okay, very
Yes,
good.
please.
So that will be it for the assumed mean. Okay, from what do you call it? An ungrouped frequency distribution table. Okay, now let's see how we can find the assumed mean from a grouped frequency distribution what's table. Okay, so quickly, let me see if we can move on to an example of that sort. Okay, so let's see. Okay, I'm going to move. Okay, I think, let me see whether I have a group data that I can use. Okay, so far, do I have a group data? I should have. Okay, so I'm going to use this. Okay, so here, let's see. We've been asked to use, so we are going to do ID, the D for this particular one. So I will use this, okay, grouped frequency distribution table to find the mean. We know that of what's the ungroup. Then after that, we'll go and look at the general questions. Okay, take note. All right, so this is what we have. In this situation, we want to find, okay, we are looking at what? Question 5. Okay, however, we want to do the D. Okay, and the D is ID. Okay, the D. Okay, the D, what are we giving? Assume mean. To be equal, assume mean A. To be equal to what? 20. Is that clear? How can the assumed mean be 20? So let's find out if it becomes necessary. I will, okay, what do you call it? You can assume any mean. You can, that doesn't really matter. Okay, it can be any value. Okay, but usually we make a sensible guess because you know that your mean shouldn't, okay, go beyond your values because it will be inside your values. And here we are looking at the value 0 up to what? Up to 40. So for me to pick a sensible mean, it should be any number, okay, between 0 and 40. But it doesn't really matter. That's what you are giving. So you work with it. Am I clear?
Yes, please.
Okay, so now you quote the formula and let the formula guide you. So from the formula, we know that our mean, okay, will be equal to, from the assuming perspective, it will be A, okay, plus sigma, okay, FD, okay, all over, what do you call it, sigma F. Okay, as we move to the next line, what do we do? Right close to the margin. Please avoid writing more than an equal to on the same line. So don't come and write equal to, equal to. Usually when we are summing the marks, we sum this. If you do your presentation or your steps this way, you know, it comes with a risk. So take notes. All right. Okay, so at this point, we know our assumed mean, that is 20. Okay, then plus, we need to go and work on this. As for the frequency again, you can find the sum of the frequency. So sigma f, yeah, will be equal to 5. Is that clear? So we also know the denominator. All correct?
Yes, please.
Okay, so what is left is the numerator. And the numerator, we will need to go and find what? The d. So you will know that, okay, d will be equal to what? X minus a per experience. So it means you will need x. Is that not it? Okay, this is a group data. Do we know the x? Can we label the first column as s, okay, column?
No, please.
No, remember we said for group data, okay, this will be in terms of classes, and x must be a value, not what? A class. So what did I say you should do when you want to find the x in, okay, a group frequency distribution table? What do you do? I'm waiting. How do you find the x? Hello, my
Find
professor.
the midpoint.
You find a midpoint of what?
The ages.
Okay, very good. All right. So of the classes. So let's see what is going to happen here. Oops. Okay, that's why I should have typed. So I will type. Okay, because I wrote, that's why it's giving me that trouble. So no issues. Okay, we can always resolve. Okay, that. Let me see. Okay, so at this point, okay, I'm going to type, okay, my sigma, okay, F, yeah, and I will move down. Don't worry at all. I will make it better. So sigma F is equal to what? Is equal to 5. So I'll make the presentation better. I'll bring it down. Okay, or maybe let me move this one up a little. Okay, so at least this is the, oh, okay, so I hope you are following.
Yes, please.
Okay, so let me, okay, work on this at least. Okay, so I think it's better now. So we are good to go. Okay, so we need to create another column for X, like you just said. Okay, so that is going to give us what? Our class midpoint. So we have what? Okay, oops, it's on capital letter. So, okay, we have class, okay, midpoint. Okay, so in class midpoint, what? X. So you put in brackets, okay, your X will come. Okay, so that will be your representation for X. So let's go and find the midpoint for each of the classes. I'm waiting. The first class, what would that be? Okay, we said the midpoint, okay. The midpoint, what do we use? We use the boundaries, is that not it? Okay, we can also use the limits. I hope you are with me. So it's not necessary for us to go and create, okay, the boundary column. Okay, so in this case, if I'm using the limit, okay, help me get, okay, all the values. Okay, very good. Okay, so now we are going to get this plus this. So your limit, you sum, then you divide by 2. So this plus this over 2 will give us 2. Is that clear? So help me with the rest of the values. Okay, oops. What is happening? Okay, so the next one, what will be your class midpoint? 5 plus 9 over 2. What do we get?
7.
Okay, 7. Then the next one.
12.
Okay, 12. Okay, you are right. Okay, we don't need the sigma x. Okay, so there wouldn't be anything here. However, okay, I will give you a very important information. That's why where we pick, we usually will pick the assumed mean from when we are dealing with a group, okay, data. So at this point, once we know x, we are in a comfortable lead. We can go and find, what do you call it, the d. Okay, because the d depends on x. So let's create, okay, another column for, okay, that. So let me insert, okay, another column, okay, for that. So what would that be? Our D. And you know your D is equal to what? Your X minus what? Minus your A. Okay, so we are going to create that for that. So let's go. For the first one, what do we get? We know our X minus what? The A, assuming is what? 20. So it will be 2 minus 20. And that will give us
Negative 18.
Okay, so let's go. Okay, so the next one, okay, so sorry. This is X, 7 minus what? Minus 20. And that will give us
Negative 13.
Okay, then the last one, okay, 12 minus 20,
Negative 8.
negative 8. Okay, so let's go and find the product of the two. Okay, that is the F and the D. Okay, that will be our last column. Okay, and sum. So please, we are left with one more column to go. Okay, so let's see how best we can deal with that. No problem at all. I'll refine it. Okay, so that's what we have there. Let me make it a little better. Okay, all right. So now we are going to look at the product of F and D. So F, okay, times D, then we can sum. Okay, so where is your F? F is this. So we'll be summing these two columns. So we'll be multiplying, forgive me, these two columns. So 2 times 18 minus 18. And what would that give us? Oops. Okay, here I'm waiting.
36.
Okay, 2 times. Let me go back a little. Okay, oops. Okay, all right. So it will give you minus 36. Okay. So let's go. The next one. It will be 1 times minus, okay, 13. And that will give us what? Minus 13. Is my point well made?
Yes, please.
Okay. And the next one, oops. The next one we are looking at what? 2 times minus 18. And that will give us minus what? 16. Am I right?
Yes, please.
Okay, so now we are going to find the sum because in the formula we need the sum. Okay, so let's go and take what? The sum. So summation of what? We are looking at summation of FD. Okay, so and that will be equal to, okay, so sum and give me the result.
Minus 65.
Minus 65. Okay, if she's right, I'm also right. Okay, so now take note. You can see that I told you that if you assume mean, okay, it's more than the true mean. Here, we've not found the true mean anyway. Okay, we are. Did we do example on finding the mean from, okay, I mean, using the true mean perspective, okay, from a good frequency distribution table? Did we do that yesterday? We did, right? I think we did. Okay, so
Yes.
let's see, we did. Okay, so now let's see. After that, maybe we'll go and find the mean, the actual mean without going through. So it means now the value here is negative, okay, 65. Okay, like I said, because the value here, the 20, okay, is above or is greater than your actual mean, when you come and sum your, okay, the product of the F and D, your result will be negative so that you subtract for you to land at the actual answer. So in effect, we are going to get this to be equal to 20, then it will be 65 minus 65, so you get minus, okay, 65 over 5 will give us,
13.
okay, so we are going to get what? 13. Okay, so obviously you know, okay, your next step will land you at your answer, so you can draw your conclusion. Therefore, if this happens to be your next step, okay, or yes, and you moved to the next page, if you want to do it that at that side, please make sure you rule a line so that it will be regarded as a page. So therefore, the mean and is mean what? Okay, age. Okay, will be equal to, and here it will be 20 minus 13, and that will give us 7. Don't forget here, you know the unit, so it will be 7 years. All correct?
Yes, please.
Okay, very good. I intentionally use only 3 just to save time. Okay, you know, once you get the 3, by extension, any number, you should be able to, okay, deal with it. Okay, all right. Okay, so it is not really necessary. It is helpful for you to state it. It will guide you as to what you are supposed to do. Because not all deviations will be x minus a. Some deviations will be x minus the true mean. Okay, so let us know the deviation that you are referring to. Is that clear?
Yes, please.
Okay, very good. All right. Okay, so I think this will be it for the assumed mean from, okay, grouped frequency distribution table. The only addition is that here you will find your x. Okay, then you move on. The other one, the ungrouped, the x is known, the frequency will be known. So the first thing you find is your d, because d is in terms of x minus a. Okay, once x is known and a will always be given, you can find the d, and you come and find the product. But with this one, you cannot find the d straight away. So even if you come and put the formula, okay, as d is equal to x minus a, you will know, assuming that was what was here, you will know, okay, I will need my x, I don't know x. So you have to come and create a column for the x. The order of your columns, okay, it doesn't really matter. Okay, so all that we need to know, or each column will be there, all the needed columns, okay, will be there. All that doesn't really matter. Okay, so I guess my point is well made now.
Yes, please.
Okay, so if that's the case, then now we can move on to, okay, the measures of what? Of dispersion or, okay, variability. Okay, so we are done with what? The measures of central tendencies. Okay, all right. So let's see what lies, okay, ahead. Okay, so now at this point, okay, I am going to take you back to where we have, let me see what is here. Okay, so the central tendency. So let me look at the variability, whether I can get it somewhere here. Okay, let me see. Okay, I think it's here. Okay, dispersion and variability is here. Okay, great. Okay, so now let's move on to, okay, our next set of what measures. Okay, when you talk of what measures of dispersion, we are just looking at how what your data is spread. That's all. Okay, and as it is stated up here, but because of time, okay, so where I introduce you to, okay, the measures of what that. So it is here. So when you get it, maybe you can read. Okay, but the basic meaning is what I just mentioned, so you can get it from there. Okay, so now the measures of dispersion that we'll be looking at, okay, will be 1, okay, the range. Okay, then 2, okay, the mean deviation. Okay, 3, we have the variance. And last but not the least, 4 will be the standard deviation. Is my point well made? So like we did for the measures of central tendencies, each measure that we'll take, okay, I will explain from the raw data perspective how to get it, from the group frequency distribution table, how to get that, as well as what, that of the group. Okay, so like I said, if you know that of the raw, you know, okay, the rest, because we know the trick in getting the formula, okay, for the rest. Okay, so quickly, let me see if I can create more room, okay, for, okay, what I'm going to do. So I'm going to take the first one, okay, the first one, which will be, okay, the range. Okay, so the first measure 1, okay, range. Okay, range basically will be equal to what? The difference between the highest observation and the lowest observation. The highest item or the largest item minus what? The smallest item. So I can say that, okay, largest observation minus, okay, smallest observation. That's all. So you can see that in normal, okay, everyday language, okay, the way we use range is different from, okay, the statistic meaning of what, of range. Usually in normal language, when you talk of range, then we are looking at a particular distance. I hope you get my point. A particular interval. Okay, but when we talk of range in statistics, range is a specific value, not an interval. So take note of that. So that would be it for the raw. Okay, then this is the formula that you use for the raw data. Okay, so for the raw data, this is the formula that you use. Okay, take note of that. Okay, that's the raw data. Okay, the basic meaning, you pick it from the raw data. Okay, also, okay, when from the raw data, because you know the observations, you can pick what? The smallest observation as well as for the largest observation. So finding the difference will be very easy. Once you know the observation, you just subtract. Okay, and the value there becomes. However, if you are looking at what? Ungroup frequency distribution table. Okay, and for ungroup frequency distribution table, let me take you to one. Okay, and you can see that again, you always, I think I can make my point here, assuming I have this as my own frequency distribution table, maybe age in years, and I'll have 2, 3, 4, 5, maybe 6. And you can see that always, in terms of the ungroup, okay, we said your observations will be what? Increasing downwards. So it means your first observation would always be the smallest observation. So this will be the smallest observation. And your last observation here be the largest observation. So it will always be the difference between this and that. So that will give us 6 minus. Is that clear? We'll go and look at specific examples, but I'm just introducing you to the concept. Is my point well made?
Yes, please.
Okay, range is always the difference. However, when it comes to, so you can equally use the same thing for, okay, ungroup frequency distribution table. Okay, let me use FDT, frequency distribution table for, okay, that. Okay, ungrouped. But for the grouped, okay, this is what you do, frequency distribution table. Okay, this is how you find the range. The range will always be equal to, so this time round, okay, it will be the lowest. Okay, let me even put it this way. The smallest of the lower class boundaries. So the smallest of the lower class boundaries, you look for it, and the largest of what? Of the upper class boundary, the difference. So I'm going to look at largest, upper class boundary. So I'm using UCB for that. Minus what? The smallest. Okay, lower class boundary, as simple as that. So with this one, it's still largest minus smallest. The largest of the values in terms of what the upper class boundaries, and the smallest in terms of what the lower class boundaries. So this is it. So assuming maybe I have this, I'm using again age in years this time around to be in terms of, so I have maybe, okay, 0 to, let me use, okay, 4, okay, to, okay, 9, 10 to maybe 14, 15 to 19. Okay, then frequency will come. Okay, I'm not interested in the frequency. I'm interested in, okay, the limit and therefore the boundaries. Okay, so here, this is how you get it. You know how to move from the limit to the boundaries. And please take notes, don't use the limits. The only in the statistical measure, so far what you've done, the only calculation that maybe definition was in terms of the limits was the class midpoint. But even that, I've told you that you can also define it in terms of the boundaries. So all other calculations must be in terms of what? The boundaries. Please take note. So this one, it will be the, okay, all the, I don't know the boundaries, so I'm going to get the boundaries now. So the boundaries will be here, the diagonal differences 1, 1, 1, 1. So I will subtract 0.5 from all the lower limits. So that will give me 3.5 here. This will give me 9.5. This will give me 14.5. Okay, 2. You add, okay, 0.5 to this, so 9.5. You add 0, so 14.5. You add 0.5 to 19.5. So if you look at the lower, okay, class boundaries, which are these? These are the lower class boundaries. Okay, the smallest is 3.5. So it means, okay, it will be something minus 3.5. Okay, the upper boundary, okay, the largest, okay, is what? Is the 19.5. So it will be 19.5. That will be here. Okay, so you subtract the value that you get becomes your answer. All correct. So always it will be your first, okay, so it will be the last observation here and not observation per se. The last, okay, boundary here minus what the first was boundary, as simple as that. But not the limit. Use the limit and see whether you end up getting the same result. What did you get here? What would this give you? 15, right?
16.
Or 16, very good. Okay, so this will give you 16. Now let's go and look at what that of the limit. If you are supposed to use the limit, then it will be 19 minus 4, which will give you what? 15. And 15 is not the same as 16. So you don't use the limit, you use the boundaries. Is that clear?
Yes, please.
Okay, very
Yes,
good. Okay, so that will be it for our first measure. Okay, today we have to finish all the measures. Okay, so let me see. Okay, we are almost 1 hour. Okay, into it. So let's see the next, okay, measure of what, especially we are done with what, out of the range. So let's go and look at our second or next measure. Okay, so let me see. The next measure we'll be looking at what the mean deviation. So 2. Okay, mean deviation. The name itself, okay, will suggest something, that you are finding the mean of the deviations. However, this time round, it is not just the mean of the deviations. And I mean this. Okay, you can see that the deviation that so far we know is the deviation from the assumed mean. But this time round, it's not the deviation from the assumed mean, or rather the deviation from the true mean. So the mean deviation makes use of what? The true mean, not the assumed mean. Please take note. That's the difference. So here you'll be looking for D again. Okay, but the D here will be each observation minus the true mean, not the assumed mean, the A. Is my point well made?
Yes.
Okay, very good. But remember we said we are finding the mean of what? Of the deviations. So in actual fact, in terms of a raw data, let's start from the raw data formula. In terms of a raw data, we are supposed to be said the mean deviation, I'm using MD for short. So MD, mean deviation, will be equal to, we said, it will be the mean of the deviation. So that means you sum the mean. Okay, sorry, you sum the deviations, I should say. Then you divide by what? The number of what? Deviations that you have. Okay, and that will give you N. It will be the same as your number of observations. Is my point well made? We are not done with the formula. Okay, please take note. However, okay, in most situations, the data that will be given, okay, will be a symmetric data. So if you find the deviation of each observation from the true mean and you sum, your numerator here usually will be 0. And we want to avoid that. So the reason why we are getting 0 is that some of the values will be positive, some will be negative. So if you add, the negative will cancel out the positives, giving you a 0 what? A result. But the mean deviation is not, okay, 0. And okay, we have to avoid this situation. So to avoid this situation, what we do, okay, to take care of what? Of this particular situation is to take the absolute value of the deviation. Okay, I will come again. You can see that it is the negatives that will take care of the positives in your deviation, because remember, even when we're looking at the deviation of observation from the assumed mean, you saw that some of them you had the results, okay, to be positive, others to be what's negative. Okay, but from the assuming perspective, it will not always, okay, cancel out. Okay, it will cancel out when your assumed mean is the same as what your true mean. So meaning it will give you 0, but it will not always be so. It won't give you an assumed mean that is the same as the true mean. However, with this situation, your D, okay, if you sum, okay, usually you'll be given a symmetric data, so that will give you 0, meaning the negatives and the positive will always cancel out. Okay, and it is the negative that is giving us that trouble. So to deal with this trouble or this problem, what do? Reduce the absolute value so that you will deal with positive values throughout your calculation. If you find a difference and the difference is negative, when you are writing it, you write the positive value. So in effect, this will be equal to, okay, sigma, remember we said the x, okay, the D here is the same as what? Okay, let me write it, x minus x bar, okay, all over what? Over n. As simple as that. So this is the formula that you need to know. Should I come again?
Yes, please.
Okay, all right. I said the basic meaning of the mean deviation is to find the mean of the deviation. But usually the mean of the deviations, okay, if you sum the deviation to give you 0. So you want to avoid this situation. When we start working with an example, you see clearly exactly what I'm talking about. So what we do is we have to take care of what will make the summation 0. That will be the negative. Because if I have positive results, only positive results, and I sum, there is no way I'm going to get a 0. So it's because of what? The introduction of negative terms. That's the more reason why you are going to have all your positive terms canceling out with the negative terms. So in that case, we have to take out the negative. And to take one way to take out the negative is 2. So if I have a number to be negative, maybe negative 2. If I want to deal with the negative, I can use absolute value to deal with the negative. So it will come out as positive. You get the point? So if you use absolute value to deal with the negative, which will make it positive, then you are looking for the mean was deviation. So it means the mean deviation basically, you know, the deviation is x minus what? S bar. We said the deviation of each observation from the true mean. The deviation of each observation from the true mean, not from the assumed mean. Okay, and that will be it. So this will be the raw data formula. We'll start using it very soon. Then B, okay, you grouped, let me ungrouped, okay, and what? Okay, grouped, okay, frequency distribution table. Okay, in this case, your mean deviation. Once you know the raw data, okay, I want someone to help me put that off what? Because of the concept that I've introduced you to the trade. How do you put the formula from the raw data perspective? Hello, who can guide us to put the formula? Okay. Hello, my professors, are you there?
Yes, please.
Hey, so
Yes,
how do
please.
we quote the formula?
Yes, sir.
So let's quote the formula. Oh, you know the trick. Okay, there is no n in frequency. So how do you get your n? Your n will be sigma f.
My F. Yes, please.
Then I said, okay, wherever you see summation, what should come after the summation?
F.
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 Then you keep your quantity that is there. As simple as that. I've given you all the tools. Just use them when you need them. Okay, it's not that pretty, but that's the formula. Okay, and you work with it. So it is the same formula for the grouped and ungrouped. Only that for the ungrouped, S will be known. Okay, but for the grouped, S will not be known. So you go and find S first before you can go and find X minus S bar. So here we are going to do a little more work. Is my point well made?
Yes.
Okay, so we'll do all the formulas. Okay, then we go and use them as and when. So let me see if I move on to, okay, I have. So we are going to look at our next measure, which will be 3. If you know this one, you know the other one, which is the variance. And the variance, okay, usually is denoted by small s squared. Okay, so the variance. Okay, all right. The variance will be the mean of the deviation squared. Remember, the mean deviation I said is the mean of the absolute value of the deviations. Mean of the absolute value of the deviation. So let me go back and maybe write it there for some of you. So here, this will be, okay, mean of the absolute value of the deviations. Okay, and the deviation will be from the true mean of each observation from the true mean. Okay, so we said this will be, your D will be equal to X minus X bar. The absolute value of D will be absolute value of this. Is that clear? Okay, however, the variance is also another way of taking care of what? The quantity that will, or the quantity that will make the sum being what? 0. Okay, so we'll say that the variance will be the mean of, in terms of definition, the squares of the deviations of, okay, each observation from the true mean. Okay, this, you have it in your various textbooks. Okay, so please take note. So in this case, we said, okay, you find the deviations. Okay, you square, then you find the mean of the square of the deviation. So the mean of the square of the deviation means you sum the square of the deviation, then you divide by the normal of the deviation. That's all. Anytime you are finding mean, you sum the quantity that you are finding the mean, then you divide by the number of that quantity. So we said is the mean of the square. So in actual fact, what we have here will be equal to, okay, we said summation of D, in this case, will be X minus X bar, okay, all squared over, okay, N. Is my point well made? So you can see that again, if you have a square quantity, I mean a quantity, and it is negative and you want to make it positive, you can square it and it will be positive. Though it will not give you positive the same value. Okay, but here it will still give you a positive quantity. So we can use squares to take care of the negative, make the negative positive. Okay, and that will be, okay, the situation. If you do this one, then if you find the mean of these values, then we are talking about the variance. Okay, so in this case, for a raw data a raw data, indirectly I've quoted the formula. Okay, your variance, which is S squared, okay, will be equal to, okay, sigma, okay, X minus X bar all squared over what? N. However, this formula is easy to quote, okay, but it's difficult to use. Very soon you will know why. Okay, so we have another formula, which will be the expanded version of this formula, and that will be sigma, okay, X squared, okay, over N, okay, then minus sigma X over N all squared. So we'll be using this very often. I don't want to bore you with the proof. We can move from here to here straight away. Okay, so we'll be using this very often. Take notes. Okay, instead of this. Okay, take note. And you can see that what you have here is the same as the mean from a raw data. Can you see it? Okay, and very soon you will know why it is easy to quote. Okay, so that's of what the ungrouped and the grouped. So ungrouped, then what grouped? Okay, frequency distribution table. So from the frequency distribution tables, okay, so now let's start from the first formula. Someone should help me put it in terms of the information that I've given you. Oh, my professors, are you there?
Yes, please.
Okay, so let's go.
Sigma fx.
Sigma.
Sigma f.
Let's come to the denominator first. That's easy.
F.
Okay, so you write
Sigma
sigma
f.
okay, sigma f. Okay, as the denominator here. The numerator will be sigma. After sigma, what comes? F, is that not it? Then you write the quantity in the raw one, x minus x bar all squared. However, the expanded version of that, okay, you know, will also be the same as, okay, sigma, after the sigma, f should come, then s squared. All over your n becomes sigma x. Sorry, sigma f. Okay, then minus, this one will give you sigma, there is a sigma there. So f should come, then x over your n becomes what, sigma f. That is the mean from, okay, a frequency distribution table, grouped or ungrouped, okay, squared. So this is just the formula that we are going to use. Okay, so that will be it in terms of what? The variance. Okay, the standard deviation. Okay, let me add the 4. Okay, standard deviation, which is the last one. Okay, that one is denoted by S. That is always equal to the root of the variance. So if you know how to find the standard deviation, then you know how to find the variance because you make use of this. So if you are looking for the standard deviation formula for the raw data, it will be root of this. Okay, standard deviation in terms of the expansion, it will be root of this. Okay, for the grouped or ungrouped, okay, it will be root of this. Okay, then the expanded version will be root of this, as simple as that. So if you know the variance, you know that of the standard deviation. If you know the standard deviation, you know that of what the variance. So if the standard deviation is given and we want you to find the variance, it means you have to square it to get the variance. If the variance is given and you want to find the standard deviation, you have to find the square root of it. As simple as that. Okay, so now let's see how best we can make use of this, okay, to the following questions. Okay, so however, let me see, we've done, okay, over 1 hour. Okay, so let's pause here. Okay, stretch, do everything possible to get ourselves activated or reactivated, okay, for the next 1 hour or so ahead. Okay, so you are welcome back from the water break. Okay, so now what do we do? This is exactly what we are supposed to do. This is the question. Okay, we are going to skip. We've done, okay, almost, we know A up to what D. So we are going to look at what the measures of dispersions, and these are the measures. So II, we are going to do the questions for II. So we'll start with IIA. Okay, so remember I told you for now, we are saying that anytime we are given a raw data, okay, we will convert the raw data to its corresponding ungrouped frequency distribution table. Then you work with it. So those of you who don't know how to do that, okay, this is exactly what you are supposed to do in terms of how to create the frequency distribution table for this, and that will be the ungrouped one. Okay, so look at your numbers. Okay, start with the list of the numbers. Okay, so 21 is the list. So you write 21. So in this case, I'm dealing with scores. So I'll write my first column will be headed, okay, scores, because I'm dealing with scores. Okay, and I will have 21. Okay, followed by the next will be 23, followed by 24, followed by 25. Then, okay, I have was 27. Okay, now because I have raw data, and in order to play it safe, a tally column will be useful. So you create the tally column that will help you get your frequencies. Okay, so you know how to tally. If you look at 21, you cross 21 and you come and tally. Okay, you cross 25, you come and tally. Okay, you know how to tally. So by so doing, you end up getting 2, 2, 2, 2 each for all that you have there. So that will help. Yes, please.
And please, 27 is only one.
It's supposed to, then it means I left one out. It's supposed to be 2. Okay, forgive me. Let me introduce the last one.
Please, and 25.
And 23 is 2.
Please, 25.
25. Okay, so it's supposed to be, let me see. No, I have to. This one, the example that you were giving. Okay, so no problem. 25. Okay, I want it to be 2, 2, 2. So 25, and the next one will be, which one again? Was it 27? 27.
Yes.
Okay. All right, very good. Okay, I think I have to do the change up here as well. Okay, I will do the change. So it was 20, okay, 5, okay, then 27. Okay, so thanks for drawing my attention to that. So that is what we have, okay, here. Okay, so now we should be good to go. This data is familiar, so let me see whether indeed. Okay, so that's it. I wanted the 2 to 2. Okay, so now this is what we have. Okay, with this, I think this is the exact situation. So we've done the correct, or the exact editing. So in this case, we are going to look at that of II, and we are looking at solution to question 1. Okay, normal your solution. You need what? Your table, which you have generated, then you come to us. So indirectly, this is the information given. Then you come to II. Okay, so IIA. Okay, what are we looking for? Okay, create a better view. Okay, so this is what we have. IIA, we are looking for the range. So the range we know. So I can draw my conclusion straight away. Okay, so the range will be equal to, we said it will be the largest observation minus what? The smallest observation. Is that not it? Okay, so now, we are going to look at, I told you in terms of the ungrouped, the smallest observation will be the first one, and the largest of, so that will give us 27, minus what? 21. Okay, and you write close to the margin when you move to the next line. So 27 minus 21 will give us what? Okay, so the range will be 6. Is that clear?
Yeah.
Okay, so we are going to look at the B. Okay, B, what are we supposed to find? The mean deviation. Okay, and we know I want to use MD, but I won't conclude with it. Will be equal to mean deviation, we said. Okay, it will be the mean of the absolute value of the deviations. So we said that is given by the formula, and here we are dealing with a frequency distribution table. So the formula will be sigma, F, then the absolute value of X minus X bar, all over. Is that clear?
Yes, please.
Please here, listen attentively. You can see that if you look at this formula, the formula has mean in it. So before you can find the X minus S bar and take absolute value, you have to get S bar. But we don't know S bar, unlike the assumed mean, where the assumed mean is given. Here, S bar is not given. So you are going to find S bar. Is my point well made?
Yes, please.
Okay, so now I will go and write, but I know that my S bar from a frequency distribution table will always be sigma Fx over sigma F. All correct?
Yes, please.
So that will inform me that I will need a sigma F value here. So I will go and find that. Okay. So let's go and do that. So we'll add on to the table always. So no issues at all. So sigma F, okay, then we are going to get sigma F, and that will be equal to, what would that give us?
10.
10, and that was what I was looking for. Okay, I wanted a pretty denominator. Okay. Okay, so in this case, this is what we have. We are good to go. We need the product of F and X, then we can sum. Thankfully, we know X. Okay, we know F. So we need to go and create what? The column for the product. All correct?
Yes, please.
Okay, so we are going to do that. Okay, yeah. Don't worry at all. I will remedy the situation. Okay, so we need a product. Okay, FX. Okay, so help me with the product. Let's go.
Please, 42.
42. Okay, very good. Let's go. I'm relying on you. The next one.
46.
Okay, so 46. Okay, the next one.
48.
48. Okay. Next, two more to go. Oops.
50.
50.
Okay. Oops, what happened? I'm coming.
54.
Okay, so 50. Then what?
54.
54. Okay. Okay, so this one is hanging. Let me bring it where it's supposed to be. Oops. Okay, I want it to be in line. No issues. Okay, so now we can go and find the sum. Okay, so let's go and do the next one
240.
again. Okay, so the sum will give us, somebody give us the answer. Okay, already. So what?
240.
You said 240.
Yes, please.
Okay, so 240, if she's right, I'm also right. So that would be the sum of what? Okay, so sigma fx. So sigma fx is equal to what? 240. All correct. Okay, I think it's interfering a little bit with my, so let me move it up a little and see if it will. Okay. Okay, it's a little better. Okay, but let me look at the best situation. Okay, so now we are in the best of position to find the mean, which will help us find what we have here. So I am going to, okay, continue here. I think we'll need more, but when you go to our copy and paste, so don't worry. So S bar, okay, will be equal to, so this implies that your S bar will be equal to, okay, 240 over 10, am I right? Okay, which will be equal to what? 24. All correct.
Yes.
Okay, so now you know what we are going to subtract from, okay, each x to get the deviations. Then you take the absolute value. Okay, so at this point, we can go and create the column for x minus x bar. Okay, then maybe the absolute value. So let me quickly go and do that. My professors, I hope you are following. If you are left behind, let me. Okay, all right. So with the measures of dispersion, usually do okay more work, as you can see. Okay, so let's see what is happening. Okay, so at this point, I am going to move on to I think I need to bring this one down. So let me do that and bring it down before it interferes again. Okay, it seems the whole of this must come down. Okay, all right. Okay, so now, okay, let's go. We can now create the column for, which one? The column for x minus s bar, is that not it? But please, in some books, they will do x minus s bar separately, then they will come and do x minus s bar absolute value. But I will ask you to combine the two. Okay, it is not risky. Okay, so in this case, that's what I'm going to do. I will go and get my absolute value. So I'm dealing with brackets. So this is what I have. So this, we said it will be x minus what? S bar. Okay, so minus S bar. So let's go and look for the S bar. Okay, so I have my bar here. So that will give me my S bar. Is it clear? Can you see that this is S bar? Hello, is
Yes,
it clear?
please.
Okay, all right. So now we are good to go. So it means we are going to concentrate on this value, okay, and the 24. So it will be this each one, then you subtract 24 from it. And you take the absolute value. So it means if you subtract and you get a positive result, you write a positive result there. If you subtract and you get a negative result, you write the positive or that negative result. Is that clear?
Yes.
Okay, so all your values here, none of them should be negative. Take note of that. Okay, so now let's go. Okay, 21 minus 24 will give us minus 3. Absolute value of minus 3 will give us 3. All correct. Hello, are you following my professors?
Yes, please.
Okay, then help me complete the rest. Okay, 23 minus 24 will give us minus 1. Absolute value of minus 1 will give us 1. Okay, so now let's go to the next one. 24 minus 24 will give us 0. Absolute value of 0 is 0. Okay, then let's go to the next one. 25 minus 24 will give us 1. Absolute value of 1 is 1. Okay, then we have, okay, the last one. Okay, 27 minus 24 will give us positive 3. Absolute value of positive 3 will still give you positive 3. All correct. Is my point well made?
Yes, please.
Okay, so now what is left? Okay, you can see that we need to go and find, okay, the product of x and x, okay, minus s bar absolute. So there is one column left before we can find the sum. I hope you are following. Because the product before you can sum is the sum of the f and the this. So but we know this, we don't know the product. So we are going to create another column, which will be our last column at this point. So let's insert another column to the right. Okay, and that is going to give us, okay, so that is what? The F, okay, times, so let me copy and paste to be better. Okay. Okay, so F times X minus X bar absolute. Okay, so that gives us what? Now let's go. So which columns are we going to multiply? Okay, obviously it will be, okay, the F column and the X minus S bar absolute column. Is that clear? So you are multiplying this and this, this and this, this and that. Okay, so let's go. The first one will give us this, right? The next one will give us 2. Am I right? The next one will give us what? 0. Okay, the next one will give us what? 2. Okay, then the last one will give us what? 6. All correct. Hello, is my point well made?
Yes, please.
Okay, very good. So let me, okay, make my way pretty. The 24 is not looking 24, so let me move it. It's 240 instead. So it's hidden. Okay, so I think now it's clear. So we are going to have, we need a sum of this. So let's go and pick what the sum, okay, straight away. So the sum of what, okay, all that we have there, and that will give us, so I'm waiting.
16.
Okay, so that will give you, okay, 16. So it's the sum of, so let me write, this should come. Let me copy and paste, it will be better. Okay, the sum of what I have there. Oops, okay, so it means the space is not enough for it. So I need to, okay, widen it. Okay, and I'll widen it a little because I need to write more. Oops, what is happening? Okay, no problem. Let me continue. I will pick it from there. So it's equal to, okay, what do we have? You said, okay, that will give us what? Did you say 16?
Yes, please,
All right,
16.
okay, so 16. So that's what you have. Let me put it in the best of shapes. Oops, it's not looking pretty at all. Okay. Don't worry, let me see how best I can deal with it. But at least my point is well made. Let me see. Oops, it's not looking pretty. Okay, still not looking pretty. But okay, the values are there. Okay, I didn't want to write. Okay, so let me see if I can work on this a little. Okay, so I have my value. So what I now have to do is I go and will substitute. So I will go and substitute. Once you substitute, then it should be good to go. Okay, I think it's better now. So let me take out this, okay, line. Okay, I will use my, okay, so then move this one to the other side a little. I will go and continue there. Okay. All right, so it's just a matter of going to substitutes then. Okay, we should be done. Okay, so we know the S bar, so we are good to go with the calculations now. Okay, so at this point, assuming, okay, I have this, I'm going to rule my line here. Okay, let me even take care of this. I know that the next one will be mean deviation. Did I duplicate it? No, I have not. So let me duplicate it before, okay, I clear it so that it will not be missing. Okay, so let me clear the whole of this to create room for what I want to write. Okay, so assuming this is my next page. So I am going to get therefore, okay, the mean deviation. Okay, will be equal to. So now let's go and substitute. Remember we said it's the summation of the pro, so it will be 16 over the summation of f, and that is 10. Okay, so that will give us 1.6. Am I right? Hey, yes, it's 1.6. Okay, usually when it comes to statistics, okay, please leave your answers in decimal.
Yes, please.
Okay, so that will give us the results that we have there. So that's it for only the mean deviation. So look at it, it's only the mean deviation. Look at the volume of work that we have done. Okay, we are now going to look at what? The variance. Okay, and once you know the variance, then you know that of the standard deviation. Okay, so we'll look at it from this perspective. Then we go to that of the group. Then it means we are done with all the measures. God willing, tomorrow we'll look at the technical questions, the questions that are not straightforward. Then after that, we'll do graph work. So tomorrow, don't forget to bring your graph, okay, book with you. Okay, and the appropriate instruments, your straight edge, your eraser, your pencils, what have you. So that will be it for the mean, okay, deviation. So let's move on to the next one. So I'm going to move on to the next, okay, one, which will be this. Oh, oops, that is not the next one. Oh, I rather did, okay, the solution, okay, on this one. So it means this one should rather go up. Oops, is that it? Yep, okay, so is this one that I need, okay, here. Okay, so at this point, we are going to clear the whole of this. Then we'll go and do the variance. So I'm clearing the whole of what we have here. Okay, so let me see if even I should have just, okay, clicked on, okay, now let me select the whole of that. Then delete, okay, and select the whole of that. We've done it already. So where we have to fall on it is the same question. We'll fall on it. Okay. All right. So we should be good to go at this point. Okay, so we are going to look at that of the B. Sorry, C rather. You've done the B. So let's look at C. C, what are we looking for? The variance, is that not it? We know that the variance is denoted by small s squared, and that will be equal to, what is the formula? We are going to use the expanded version of the formula, and that is sigma fx squared over sigma f, okay, then minus, okay, sigma fx over sigma f, the whole of that squared. Okay, so this is all that we are going to do. Let's see whether we can take care of some of the columns. Okay, so in this case, I know in the formula, I will need S squared, then the product of F and S squared. No issues at all. Okay, I will teach you how you can easily get this without struggle. I will need my sigma F, so I know that I will need my Fx, no issue, because the Fx, I will need it here, it's here. So it's needed there, it's there. So I don't need this, I don't need that. So I'm going to clear the whole of that. Is that clear?
Is the Hackman.
Yes, please.
So in like exams, we need to do all the columns.
Yes, all the
See
columns
the
that you need, you have to do them.
okay.
So
So then
you
when
look
I
for it,
erase it, you need it.
whether I didn't hear
Pardon?
you well. Hey, come again.
I was saying that as you are cleaning this table, this column right now, in exams, like we'll have to extend the table and add what we're coming to do.
Okay, so usually, in exams, won't give you this loaded.
Okay.
Okay, hey, because I want us to solve, so you won't get one question which will be loaded this way. Okay, for you to add more. So maybe we'll ask you to find either the mean and the standard deviation. So
Yes,
you keep
please.
on adding, okay, until maybe your columns, okay, I mean your space here, then you come down and create another one. Okay, all
Yes,
right.
please.
So here, remember we said f of x is known. Okay, so what is left is fx squared, is that not it?
Yes,
All
please.
the parameters here are known. Okay, what is left is fx squared. So now let's see. Okay, how do we create the column, or how do we find fx squared? Let me see. So I'm going to write it here. Okay, x squared. We'll need that before we can sum. Okay, because that's the meaning of what we have here. So how would you do that? You find s squared, then you multiply it by f, I guess. Is that what you would do?
No, please.
Okay, so what will you do? If your answer is no, then tell me what you would do, or you won't do anything.
No, please. Since we already have sigma fx, we'll just square it. And we'll just, square the number.
Hey, wait a minute. Asemwaba.
Okay, no, you rather make a table.
Do you know why? Because what you said, let me delete, okay, that column, I don't need it. Okay, so the entire column. Okay, so because of what you said, the meaning of what you said is this. Okay, you are assuming what you have is the same as f of x squared. It's not the same. This is f squared, s squared. Princess, you get it? But here, it is the product of f then s squared. So how would you get this column? Oh, hurry up, my professors.
Yes, please. Yes, please.
So how would we get that? Okay, usually in books, you see s squared there. They will create a column for s squared, and you multiply it by f. But I will advise you don't do that. It's not necessary. You know fx. So this is the same as fx times x. You can see that fx squared is the same as fx, okay, times x. Do you agree? Hello, do you agree?
Yes, please.
Okay, so it means you have all the needed columns. You have fx, you know your x. So it's just a matter of multiplying this and this, multiplying this and this. And that would be. Don't go and create s squared, okay, separately, follow a column for that, then multiply it by f. Is that clear?
Yes, please.
Okay, all right. Okay, so Kobe, well noted. Wait for the video, then you do the needful. Okay, so now, okay, help me do the products quickly. I'm relying on you. Okay, this times this. I need to type. I don't have to write. So let me go and type. I'm waiting. So hurry up. Okay, we need to do that of the What do
8,
you
8,
8
8, 2.
882? Okay, here, let's go.
1058.
1058. Okay, mention it in terms of digits.
1152.
1152. Okay, if she's right, I'm also right. Please make sure you also verify because immediately one of them is wrong. We are doomed.
1250.
1250.
0.
Okay. All right. Then the last one.
1458.
1458. Okay. Okay. So this is what we have. Okay. So now we can go and generate the sum. Okay. So let's go and get that of the sum. Okay. So it will be the sum of what? Fs squared. So sum of what? F. Okay. Then x squared. I think I should have even copied and pasted. But okay, no issue. So I've started already. So let me go and bring the s squared. Okay. And that will be equal to, so I'm waiting for the sum. Okay, I guess you are doing it, so I'm waiting.
5800.
5,
800.
800. Okay, please, do you agree?
Yes.
Okay, all right. So if that's what you had, then okay, we are all right. Okay, so now let's move on and find, okay, go and substitute and find whatever we are supposed to find. So it means now what we have here will be equal to sigma fs squared, that is what? 5800 over your sigma f, which is 10. Okay, then minus sigma f, I think we've done this. Okay, the mean gave us, this is the same as the mean. The mean gave us 24, am I right? Otherwise, you
Yes,
still come
please.
and do 240, okay, over, you can substitute directly over 10. Okay, all squared. Take note of that. We are not done. Okay, let me go and clear what we have there, then we continue. Okay, from there. So assuming this is my next page, we are almost done anyway. Okay, so if that is my next page, I will rule a line there. Okay, so what are we going to get? We are going to get that to be equal to, and this will give us 588. Okay, then minus what? This will give us, let's simplify this, which will give us 24.
This is 5800.
Is 00. Oh, forgive me. Okay, so 10 should be here. Okay, then what? 4. Okay, 24 then squared. Okay, so at this point, come and deal with the square first. Okay, so give me the square of that. Then your final answer will come. You draw your conclusion.
No, I mean it's 5800. Like there's no two. It's not 2 8s.
It's not 2 8.
It's
It's 5800.
No.
Okay, it was rather 00.
Yeah.
Forgive me. Oh. Okay. All right. Okay, so 800. So it means, okay, this shouldn't be. Okay, so this shouldn't be there. Okay, I will deal with it later, so don't worry. Okay, so we are going to get 580, 580. It's right now, right? Okay, so I'm waiting.
Yes.
24 squared.
576.
576.
Okay. Okay, so that's what you have. So therefore, your variance, okay, is equal to here. We are waiting. The difference.
4.
4. All right. Okay, so that will be it. You don't have any units, so you end there. Remember, all the measures ordinarily are supposed to have units if it's given. If it's not given, you leave it like that. Is that clear?
Yes, please.
Okay, so again, I'm going to duplicate it. Okay, then we go and find the standard deviation, but we won't stress ourselves anyway because we know the variance. So in this case, I want to delete this. Okay, so let me delete this one and create more room for the D. Okay, so D is the standard deviation. So D, standard deviation. And that will be comma S. And that will be equal to, remember we said it will be the square root of the variance. So if you have found the variance, then this is the formula that you've used. However, if you've not found the variance and you were asked to find the standard deviation, then you put the formula this way. S will be equal to root of the whole of this. Is that clear? Then you go and substitute. So this will be equal to root of 4. Okay, which will be equal to what? 2. Afa. Is my point well made?
Yes, please.
Okay, so that will be it from the ungrouped frequency distribution table. If you know that of the ungrouped, you know that of the group. The group, the only difference is that you will go and find your X, which will be your class midpoint. As simple as that. Then the rest will be, okay, exactly, okay, what we did over here. So let's see if the next set of examples will move us into, okay, so let's see. Okay, I think I will walk you through the other examples. Okay, where I need one situation. Okay, so let's look at this. We are going to find, I think, the measures based on all that we have here. So we are going to do the range, okay, as well as what? The standard what? Deviation and the variance. Okay, for the group, then we are done. Your assignment will come. Okay, today we'll go a little beyond. Okay, so here, fortunately for us, okay, I can, okay, use this table, fortunately. Okay, so let me see where the table is. Fortunately, I can use this table. Okay, so this is where the table is. So let me duplicate it, or it's already duplicated. No. Okay, so I will duplicate it, okay, so that I don't waste time, because some of the parameters that I need are there. Okay, so let me clear the whole of this. Oops. Okay, so we should be good to go. So we are still looking at 5. By this time, we are looking at 5 II up towards, okay, the A up to D. Okay, so quickly, let's go and see which of the columns will, okay, take out and the ones that we will. So I will come down because of experience. Okay, so that's I keep on adding. Okay, no issues. So I'm going to have II. Okay, so IIA, the range. Okay, you can get the range straight away. So therefore, the range will be equal to. Okay, the range from a group data, how do you find it? Hello, my professors, please. Okay, let me know. How do we find it? We said that would be
Largest
V minus what? The lowest, okay, lower class boundary. Very good. The smallest or lowest. Okay, so perfect. So here, what you have here are in terms of limits. So you have to move it, okay, from limit to what? Boundaries. Take notes. So now this is what we are going to get. Okay, so we will look at the diagonal differences 1. So you have to subtract, okay, the, what do you call it? 0.5 from the 0 and add 0.5 to 14.5, because these are your values of interest. Your first value here, its boundary, okay, then, okay, this value here in terms of boundaries. So that is going to give us, okay, 0 minus 0.5 will give us negative 0.5. Also, but it will subtract. So you let me, hold on. Okay, I'm coming. Okay, so let me write the 14.5 first. Okay, I think I can go back because I'm in the editing mode. Okay, so now what do we have? We have 14.5. Remember, you add, okay, 0.5 to the upper, okay, bound limit to get the upper boundary. Okay, then minus your, what do you call it? Minus 0.5. So minus 0.5. Okay, so in effect, we are going to get, okay, plus 0.5, which will give us what? 15. Is that clear?
Yes, please.
Take notes. Okay, so we are done with the range. Where, okay, the real work will begin is where we are going to look at. So let's go and look at that of what? The B, the mean deviation. So mean deviation, okay, we know, okay, MD sort of, okay, in terms of the grouped or ungrouped, the formula will be the same. So sigma F, the absolute value of X minus X bar, okay, all over sigma F. Okay, so we need to go and find X minus X bar. So in this case, I'll write again, but my X bar, okay, I should say, I will need it to find my X minus X bar. So that will give me sigma Fx over sigma F. Okay, so I need to go and create a column for, okay, Fx. I don't need this column, so I'm going to clear it. Okay, I will need this column to be Fx, not Fd. Okay, so I will, okay, do that. I know my F, I know my X, so help me complete this table. Hey, let's go. The first one becomes, oops. The first one becomes this times this, which will give us 4. Am I right? Oh, quickly, let's go. Okay, 7, that will give us what? 7. Okay, the next one will give us 24. Am I right?
Yes, please.
Okay, so sigma Fx will give us, I'm waiting.
35.
35. Okay, so 35. Okay, so we are in a comfortable lead. So at this point, we will go and get our, okay, so it means this implies that your S bar will be equal to 35 over sigma F, which is 5. So that will give us 7. All correct.
Yes, please.
Okay, so once you know S bar, okay, we know X minus S bar absolute. We are going to create a column, okay, for that as well. So let me quickly do that. Okay, insert, okay, a column. Okay, don't mind if it changes. Okay, I will deal with it later. So we are going to look at what? X minus S bar absolute. So let me go for my absolute value. Okay, then, okay, type the X minus S bar, oops. Okay, so S bar will be here. Take note. So it means we are going to have what? You know your S bar 7. So you subtract 7 from all the S values here. The class midpoint. You know here you will find your class midpoint. You create your S value. Okay, take notes. So you find this before you can go and subtract. So you don't know your X, you don't know your S bar as well. Okay, so you go and find your X before you can find your S bar, because even your S bar will involve X. Okay, so now let's go. X minus S bar. So 2 minus 7 will give us minus 5. But absolute value of that will give us 5. All correct.
Yes, please.
Okay, then 7, okay, minus 7, that will give us 0. Okay, and okay, the last one, okay, 12 minus 7 will give us what? 5. Okay, so absolute value of 5 is 5. And you can see, assuming we didn't use the absolute value, you see that you get minus 5 here and 5 here. Like I said, the data will be symmetric. So if you sum, you get your 0. So it means automatically your mean deviation is 0 because the numerator is 0. So that's the more reason why we use the absolute value, okay, to avoid this particular situation. Is that clear?
Yes, please.
Okay, very good. So now this is what we have. Okay, so you need another column, which will be the product of this and that. So we go and create that column. Okay, so let's do that quickly then. Okay, I think we should be done for the day. So we need the F. Okay, so I will need F times. So let me copy this one and paste. Okay, here. So that gives me what I have here. And this will be equal to, so you know this, okay, and you are going to multiply it by the F. Okay, my table is not looking pretty at all. Let me see if I can make it a little better. Okay, maybe it's manageable. I'll refine it later. So what do we have? F times this. So that will give us 10. Am I right?
Yes,
Always look
please.
for your columns of interest. Okay, then this times what? Okay, so you are looking at this times. Okay, this, that will give us 0. Okay, the next one,
10.
okay, 10 again. Okay, so we are good to go. You can find the sum. Okay, so we go and find the sum, and the sum, okay, will give us sum of what? Okay, what we have here again. Let me copy, okay, and paste. So copy and paste. Okay, and that will be equal to, you said it will be what, 20, obviously.
20.
Okay, so we are good to go at this point. Okay, let me see if I can, okay, make the table a little, okay, move this one. So it's just a matter of going to substitute. It's just a matter of going to substitute our found sums. Okay, and that will be it, okay, for what we are supposed to do. Oops. Okay, so let me see. All right, it's not looking pretty, but we'll manage. Okay, so now what do we have? I will go and write therefore, okay, my mean deviation. Okay, will be equal to, hey, so let's go. We said the summation of this, which we had 20 over
5.
over 5, which will give us what? 4.
4.
All correct. Is my point well made?
Yes, please.
Okay, so at that point, I can clear this. Okay, the whole of this. Let me see. Okay, then create room, or maybe I will duplicate it and go and do it in the next one. So let me duplicate it. Okay, so I'm going to continue here, but I will clear the whole of this. Okay, so we are left with what? The variance and what? The standard deviation. I've told you, once you know the variance, the standard deviation is known, and vice versa. Okay. Okay, so let's see what we are supposed to add here. Okay, so we are looking at C. C, variance. You know the formula. The formula will be equal to sigma fx squared over sigma f. Okay, then minus sigma fx all over sigma f, the whole of that squared. All correct.
Yes, please.
So here you need your classmate point, which we have already. Okay, and you need fs squared. You have fx, so I will not need this. So this can go. Okay, I'll rather need fx squared. So let me label it as such, fx squared. Okay, so let me pick that s squared from here. Okay, so s squared, that will be, okay, so that gives me, let's go. It will be the fx, okay, times your x. So it will be this times this, so that will give us 8. Am I right? Then this times this, that will give us what? 49. Am I right? Okay. Hello. This time, this will give us. My professors, are you there? We are almost done. Okay, so
Yes,
Yes,
okay,
please.
so 24 times 12. What are we going to get?
188.
188.
288.
Okay, so 288. All right. Okay, so this is what we have. So now what do we need? all that we are supposed to have here, we have it. We just need the sum. So this, we don't need it, so we'll clear that. So let me quickly delete that so that maybe it will make my work better. So delete, okay, that column. Okay, then I can create room, okay, for a better, okay, so I think now it's looking prettier. Okay, so we need a sum. So I'm going to get a sum. And what do we do? Okay, summation of fx squared, you will need it. So we are going to indicate that over there. So fx squared. So let me copy and paste. Save time. Okay. Okay, and that will be equal to, so let's go. Give me the sum.
631.
He said what?
641.
641.
Yes, please.
This is 3, 4,
Are you
5.
sure? Are you sure?
342.
3, 4,
Hey,
3, 4,
because this
5.
cannot even go beyond. Okay, so it's supposed to be what?
Oh, yes.
3, 4, 5.
342.
3, 4, 5. Please, Ejumani, now why you've done all the work. Don't let
You
the sound
sure?
be a problem.
345.
Okay,
Sorry.
all right. Okay, so 3, 4, 5. Are we right now?
Yes, please.
Okay, so I wanted so let me create more room here. Maybe it will move. Okay. Okay, so now it's better. Okay, so at this point, we are going to carry out our substitution. So this will be equal to, okay, 3, 4, 5 over, okay, your sigma f, and that is 35. Okay, minus, okay, sigma fx, and you know that one too is 35, over sigma f, which is 5. But that's not all, the whole of that squared. Okay, so if you continue, we are going to get, okay, let's simplify this. What do you get? 345 over 35.
Mr. Hackman.
Mm-hmm.
Please, is it not over 5?
Which one? I wrote over 35. Over 5, please
Yeah.
forgive me. Okay, be careful as well.
This is 69.
It's what?
69.
69.
Yes.
Okay, then minus this we know will give us 7 squared. Is that clear?
Yes,
So we are
please.
going to get 69 minus 49. Am I right? Which will
Yes,
give
please.
us
20.
20. Okay, so you could have done your conclusion here, or I can still come and write therefore here. Then my conclusion is good. Is that clear? Okay, and for the standard deviation, I'm going to clear this. Okay, then we will do the standard deviation there. Then we are done. Okay, so in this case, we are going to get what? Okay, D. Okay, standard deviation. Okay, will be equal to, and we know, let me write therefore here. I know it will be root of what? The variance. Okay, and I've told you I'm using this because, okay, I have, for you, let me quote the formula so that, okay, if you have done the variance, then you quote it this way. Okay, so let me use the other approach so that you can appreciate. It will be root of the formula, sigma fx squared over sigma f minus sigma fx over sigma f, the whole of that squared. Okay, so which is the same as what you've done over here. So that will be root of what? 20. So that gives us 2 roots of what? 5. I've told you usually, if possible, leave it in terms of decimals. So we'll ask you to approximate it. Is that clear? So you get the decimal representation, but the decimal representation, okay, your first approximation should be 4 dp. So let's get the 4 dp approximation. I'm waiting.
$4.4721.
Okay,
4721.
4.4721. Okay, no units. Okay, so there is So it means all the ones that we found, we should have attached the units. So with this one, okay, please don't forget there is a unit, so attach. Okay, and this will be for BP. Okay, remember I've told you, so this one will also be yes. Okay, there we go. That will be it for, okay, all the measures. Okay, but usually questions will not be straightforward like this. Okay, so this then becomes your assignment with notes. Okay, I want to leave a particular question with you. Let me see if I have one group. Yes. Okay, so this one, okay. Okay, so I think we'll look at it together when we come to, but please try when we meet tomorrow, because tomorrow we'll be solving general examples. Okay, so this one will be yours, but you present the solution to only, I think, I'm interested in only the mean deviation and that's of what the standard deviation, because I know that if you are able to do the standard deviation, you've done the variance. Okay, so you will do this one. Okay, let me underline or make it bold. Okay, and this one only. Take note, the rest we will discuss that, okay, tomorrow. So do the mean deviation of this and the standard deviation. All correct?
Yes, please.
Okay, so I'll capture it and put it on the platform anyway. So make sure you try, and tomorrow don't forget to bring your, what do you call it? Your graph books and the appropriate instruments. So thank you very much. Okay, please. Okay, God bless us all for making the class a success. Okay, so bye-bye.
Amen. Bye.